These are the things I like on Postgres. Concerning the terminology, I hope all of you are Oracle DBAs, or you might be Postgres DBAs who want to understand something from the Oracle world to be able to offer some migration project and so on. So do not expect a rocket science, but the first word I was scared about is cluster. For me, as an Oracle DBA, cluster means real application clusters. Well, the Postgres community used the same word, but it means something completely, totally different. Just a spoiler, it's a pointer to a directory on a file system. We will talk about it later in a bit more detailed. Instance, it's nice. It's a software loaded into the memory, serving the purpose of what we have the database for. So it serves the customer queries, manages the data. It's almost the same, except the different relation to a database, which is set of files on disks. Nice, this is the same as within Oracle. Tablespace has a totally different meaning to my understanding, but there are still something in common. We will explain it later. From the logical point of view, roles are almost equivalent of the operating system groups in Oracle. Unfortunately, users does not exist in Postgres. They are only roles with the special grant with login. So we have roles in Postgres, and some of the roles might be used to connect, and some of the roles are the same purpose, what we know them from the Oracle database. For convenience, there are still commands create a user in a Postgres, but behind the scenes, it will create a role with the connect ability, with the login permission. The scheme, it's nice. The scheme is something what does not exist in Oracle. It's the word which is used to describe a set of objects owned by a specific user in Oracle. Whereas in Postgres, the scheme is honestly, it's a namespace, it's an existing object, and it's a grantable object, so we will cover it later on. What's the difference in scheme between Oracle and Postgres? And one of the words I was also scared about was a tuple, what it means for all the hell. So I've asked Wikipedia personally, found an answer, and created a shortcut. Well, think about it as a row simply. What I strongly encourage you is read the architectural fundamentals. It's not that long as it looks to be. You don't have to memorize it, but if you go through the documentation, it gives you a good overview how the engine internally works, how the components interact together, and how the user queries are being solved. So don't be afraid, open the documentation. It works as a link within the presentation, and just briefly scroll down to get an overview what is inside the documentation. This is probably well known for all of the Oracle DBAs, so well, at this point, no. Okay, so we do have a database, there is an instance, which is a piece of software loaded into the memory, working with a set of database files which the database consists of. We have something which is called Oracle Home. This is an environment variable pointing to a directory where the software is installed. And for sure, from one installed software, we might run multiple instances, and we can have different versions of the software installed on one machine. And the instance works exactly with one database. On Postgres, there are similarities and differences as well. There's no something like PostgreSQL Home or Postgres Home. We have just a simply installed software, and yes, we can have two different versions of a software installed on a single operating system. We can run, similar to Oracle, multiple instances from the installed software. And the key here is the PG data, which is environment variable pointing to the database cluster. I mean the directory on the disk. So we might run the 9.4 database and point it to the PG data directory, which is the cluster name. And within the PG data directory, there are multiple databases. Some of them are internal, The blue ones, it's a template 1, which is very useful. You can modify it, and if you create a new database, the template, your modifications made to the template is used to create a new database. And there are something like application databases. All of them are served by one instance. So this is the big difference. When we are running Oracle, the instance of Oracle always manage just exactly one database, where in Postgres you can find it similar to Sybase or SQL Server. The instance can and usually manages multiple databases, and the same applies for another instance loaded, regardless if it's from the same version software or a different software, but definitely those instances has to point to a different data directory, the cluster, the Postgres cluster referred by the PG data environment variable. So if I try to compare it, this is the Oracle scheme. We do have a database which is managed by exactly one instance running from a software, whereas we do have a software loaded into the memory. This creates the instance, and this instance is responsible to manage multiple databases within the context of one instance. With version 12, Oracle incorporated the new feature called pluggable databases. So it seems that this idea that one instance can manage the multiple databases makes some sense even to Oracle. What a database consists from? Probably a well-known picture. There is a database which consists from data files, control files, online redo log files, and undo table space for the old version rows. There are some additional files like parameter file, password file, and archived logs, which are not part of the database, but you need them, at least those two on the left, to get the instance up and running. And the archived logs are crash protection managed by Oracle Archiver process. In this case, I've tried to create real application clusters. So we have multiple instances, but still each instance manages just exactly one database. And the feature of real application clusters is that we can have multiple instances on different machines working concurrently within the same files. But imagine there might be one instance, the scheme will be the same. How it works with Postgres. The instance is represented by the process in the memory. So the process which starts the database is usually called a postmaster. The parameter, the database cluster. This is the content of the PG data environment variable. So we passed the directory name to the postmaster, which is starting the database. And optionally, we can add some parameters like a different port than the default where the Postgres instance listens for connections. The physical structure, what is there, what we can find within the database cluster, especially the base directory. It's a directory where the default table space of Postgres resides, and it exists always. There are some configurations files, host-based authentication called ident, and the Postgres configuration itself. If you wonder what is the content of the base directory, it looks like this. There are simply another directories called by numbers, and you can issue a simple query to get the object ID which corresponds to the directory name on the disk. And if we look inside one of the databases, we can see some files. It's again based on object ID, and there is a data file itself, free space map, which is self-descriptive, and the visibility map, which can tell us which rows or tuples from the table are visible to transactions and which are no longer visible to any transaction. There is, on the slides you can download, there is a small link to a documentation. Content of all the directories is well documented. so there's nothing hidden, there's no magic. For example, the PG tablespace is a directory holding the tablespaces or symlinks to another file systems where the tablespace might reside. If we try to match it to the Oracle structure, starting with the data files, as I mentioned, there is a directory for database and data files resides inside. The PG HBA conf, which is a host-based authentication file, is almost equivalent for SQLnet Aura, where you can define invited nodes or excluded nodes. So this gives you control which source IP addresses might connect to which databases. PGXlog holds files for transaction logs, which is almost equivalent of the online redo logs. PostgreSQL is an equivalent for the parameter file. And I would say the password file and control file are somewhat part of the default Postgres database. There's no archived logs because Postgres covers the transaction logs archiving a bit different way. There is a configuration parameter called archive command, and instead of building the process responsible for archiving the transaction logs once they are full of data, Postgres simply call another command defined by you as a DBA to copy the data file somewhere else. Tablespaces. I would strongly recommend to read this wiki page, where is recommended file system layout. Personally, I use for each and every database separate file system, as well as I use separate file systems for transaction logs. This gives me a chance to not to be afraid of that if one database, for whatever reason, grows and unexpectedly fast, this will not affect by the fooling the file system other databases. I can archive the transaction logs to, let's say, rotating disks or remotely to different machine to protect them in case of failure. And tablespace might be used to define the different tiers of storage, so you can use SSD disk for, let's say, some online data or indexes if you want, and rotating disks where the archived old data not being accessed daily might be there, and if you run reporting from rotating disks, they perform very well for the full table scans, there's no problem with them, whereas the random access is not a good for traditional disks. So, temporary tablespace might reside on unprotected storage, because if you lose the temporary files, it's not a reason for a corruption of your database. Until now, I haven't mentioned the undo tablespace. Thanks to the multi-version concurrency control in Postgres, we do not have anything like undo tablespace, and we do not have the snapshot to alt exception, except it's being involved again. So now with version 9.6, there is a special parameter which might allow the DBAs to create the snapshot to alt exception, but this is a prevention for having too long-running transaction instead of anything else. By a principle, the multi-version concurrency control allows each transaction to see only the raw versions which has been committed before my transaction number. So we have a high throughput. Writers never block readers, and there's no log contention. As an additional, we can run a serializable snapshot isolation mode, which is, I think, it's only a special use case. I'm not aware of any application running that way. But how it works, if there is a change within the database, what Oracle does is the copy, modify the block in the memory, and create a before image in the undo segment. Since the undo segment is a tablespace of limited size, you can get the snapshot to alt error. Or if you have properly set the undo tablespace, most probably you will not suffer from it because it will be recycled as a cyclic buffer. With the multi-version concurrency control, we do not need separate undo tablespace. The before images are stored within the database. What Postgres does is when we update a row, it simply creates a new row with the updated data, with a new transaction ID, and the old one is there. And if we delete a row, it's just marked as deleted with the transaction ID. So each transaction knows exactly which rows are visible in their context. Online redo logs, they are called write-ahead logs or X logs. It's the transaction logs in Postgres. So online redo logs in Oracle are managed by the archiver process if we run the database in archive mode. In case that the archiver process is not fast enough, your database simply freezes and waits until the archiver finishes its work. There is a static configured amount of redo log groups which you can add on the fly, but it's a static from the point of view that it's not dynamically changes based on the workload. And you have to do some log switch tuning. I mean the online redo log size and the amount of the groups. Write-ahead logs or X logs in Postgres are cyclic buffer as well, but it does not seem at the beginning to be that way because the file name changes and changes and changes. Honestly, once a transaction log or X log is no longer needed in Postgres database, Postgres will rename the file, so there's no need to format the binary the content of the file, and this way it might be reused for new transaction data. Archive command, as I've already mentioned, is something what is up to the DBA to configure. It might be a simple copy command, or it might be rsync, whatever you decide. Postgres still provides some parameters with the name of the file to be archived, and it's up to the administrator to manage the copy. Usually it's a remote copy just for data protection, so there's no archiver process built in the engine itself. If it succeeds, Postgres is happy. If it fails, it is mentioned in the log file. So usually it's at least you have to test whether the same file name already exists on the target, and if not, you might copy the archived file. Very well documented, and there is an example in the configuration file, so no need to scary about it. What I advise again is to put the archive files at least on a separate file system, or even better, ship them using rsync to a different machine just for data protection. As I have mentioned, put WAL files or transaction logs on a separate file system. Starting with version 9.5, the configuration is easier because there is a min size and max size parameters for the definition of the amount of the transaction log files you want to have on your file system. By default, they are 16 megabytes each, but you can compile Postgres to use a different size. Honestly, I've never seen installation which requires this change, but it's possible. And for the previous version, there is a parameter called checkpoint completion target. It's out of scope of this discussion, but we can explain it if you want. And checkpoint segments is the parameter which tells you how many transaction logs is intended to have on the file system always. Or if you have replication in place, the wall keep segments might be the parameter which is higher than the previous one. But please bear in mind, this is in both configuration ways a soft limit. So in case there is a high transaction throughput, you might have more than this amount of transaction files. This is the reason why I always advise to put the transaction logs, the xlog directory, create a symlink, put it as a separate file system, because in case of whatever goes wrong and I'm receiving much more transactions than expected, it will not make the file system where the database resides full of data. So the database will crash, the instance will crash if it runs out of space for the transaction logs files. But you can start it again and recover from it once you add more space to the transaction log files. So no risk for losing the data. And as is any other system, you have to learn what amount of free space on disk is necessary to have your system running smoothly. So it's a soft limit only, and be aware of it. One more thing to mention. If the workload peak disappears, the Postgres automatically decreases the number of the checkpoint segments or wall segments, xlog files, to the amount of configured, the volume or corresponding checkpoint segments configuration parameter. How we can run the instance? The archive mode itself has the configuration option off, so we are not archiving the data. The archive command is not called, and even it's not necessary to have it defined. Or we can run the database with the archive mode switched on, which means that the archive command is used. And there is a configuration option always, which means that even of a replica, in Oracle terms, on a standby database, we want to archive the transaction logs even on the standby database. Similar to what Oracle provides, the wall level defines how much data is being logged to the transaction logs. The minimal provides only a crash recovery, so the archive command is not necessary because it uses only the xlog files exactly like you run Oracle database with no archive log mode. What you have in your online redo logs might be used for crash recovery, and the same way works the minimal value configured for wall level. Replica is the level added in version 9.6, which honestly combines from the previous releases known archive and hot standby wall logging levels. The archive, as it means, is almost equivalent if you use only log shipping on an Oracle database. So it provides enough information to be replayed on the standby or on the replica in terms of Postgres. So you have available recovery instance where you can recover from the transaction logs, but you will lose the data which has been shipped or created in between the 16 megabytes of the transaction logs. So these are increments. Exactly like in an Oracle database when you transfer the archived logs only. And the hot standby, it adds some more data to, it adds slightly more data to the transaction logs. So you can run the replica or streaming replica on Postgres, and it provides you the ability to open it for queries. So it's almost equivalent of the Oracle Active Data Guard feature, available instantly in Postgres with no license cost. And the new feature is called Logical. It's a support for logical decoding. It's almost equivalent for the Oracle Logical Standby. The nice thing is that it probably will be part of version 10, so you can use it from version 9 to use a logical replication to version 10 and perform the upgrade once you get those databases synchronous with a minimal downtime. You can upgrade your engine between major versions of Postgres. Memory, not yet covered, so this is the well-known structure of the memory and the processes in Oracle. What I want to mention, DB cache size is almost what shared buffers configuration parameter means in Postgres. So this is the amount of memory available to the pages of your data files to have in memory. Sort area size, or PGA, aggregate target, is almost what might be called workmem and temporary buffers, where more workmem is a memory which is available to each node of your query. So it is not a once per query, but once per each node of the query if you look at it as a graph. So do not set it too high, but it allows the query to operate efficiently for sorting in the nodes of the query if it's necessary, and so on. And block buffer size in Oracle is almost what wall buffers parameter is in Postgres. There are two additional parameters: maintenance workmem. This is an amount of memory which is almost like the workmem, but only for selected operations. If you run vacuum or if you run a create index, then it might be beneficial to have much more memory to do the sorting within the memory and not spilling to a temp file on the disks. And basically, at least these two commands are where maintenance workmem takes in place. Effective cache size is a hint that we can tell the Postgres instance how many cache the operating system has available for caching the data from the disk. So this is an advice to the optimizer how much pages might be retrieved from the operating cache instead of a real physical read from the disks. The Oracle database structure, I think it's well known. We might have a database which consists from a set of table spaces, and the table space consists of segments, which is built up on of the extents, and the extents consist of Oracle blocks. The table space consists of from one or multiple data files, and for sure the data file is made of operating system blocks, and the data file refers to multiple extents from the logical side. How it looks like in Postgres? Well, we have a Postgres cluster, the directory where all of our databases reside. So there are multiple databases within the Postgres cluster. There are objects within the database, tables, indexes, and here consist of 8K pages. Might be that you compile Postgres with a different page size. Again, I have never any reason to doing so. The table space is cluster-wide object. It does not belong to a single database. This is something what you configured at the Postgres cluster level. So it means that a table space, I mean, it might be used for, let's say, different disk tiers or separating databases to different file systems. And within the table space, and the default is always there within the base directory, database objects, the files physically resides on the disk, and it consists of operating block. The thing to know is that multiple different databases might place their files in a table space. Whereas in Oracle, table space is unique to a database. On a Postgres, it's unique to a Postgres cluster. So databases might share a table space. For example, if you use it for tiering, you may have a table space on SSD disks, and multiple databases might have some data on the SSD disk within the table space. PG data is the cluster, PG default is the default table space, and PG table space contains symlinks to the directories holding the additional user-created table spaces. That's so complicated. This is the same what I've tried to describe. So I might have the default table space and custom table spaces, and multiple database might have their files in multiple table spaces, and different databases might have their files within the same table space. Connections, Oracle use a listener process where we have a listener for network restrictions or configuration, and usually a dedicated server process is used. On Unix systems, and multi-threaded server is available on Windows. You can use it always on a Unix platforms, but I think it's quite rare. Whereas Postgres has a master process called postmaster, which listens for new connections and forks itself to create the processes which serves the individual connections. PG, HBA, conf defines the restrictions, which hosts might connect to which databases and which users. PostgreSQL.conf is the main configuration file, always a dedicated server process per client. And if you need some kind of connection pooling, use PG Bouncer, please. PG Pool is, I think, too complicated to have it up and running, but it's an option if you need it for some reason. What I want to highlight is that Postgres trying not to reinvent or re-implement what is already available. So if there is a caching on operating system, it relies on the cache. That's the effective cache size configuration parameter, how much memory the operating system has available for caching the file system data. Whereas Oracle wants to control all things on its own. That's probably why ASM is available. By the way, I think ASM is a great piece of work, originally invented by Digital. Some things about security. As I have mentioned, in Postgres we have only roles, not users. But if the roles is granted with the login permission, it acts as a user. What it means is more general, so you might switch to a different role, which can be a login role. It's almost equivalent if you use a switch user on the operating system. You can do it in Postgres. That is, I think, amazing. A scheme in Oracle is a list of all objects owned by a particular user, whereas in Postgres it's a grantable namespace object, and once it's grantable, multiple different users might have their tables and schemes. I always encourage people to use the schemes just to have things organized, even if it's not necessary. Public scheme is there. In my databases, I always simply drop it to have some elemental security available, because as public means, any user might connect and create a table. If you drop the public scheme, unless a user is granted to create some objects within the scheme, they can't overflow your Postgres cluster with nasty data. Just the yellow lines are important. The picture means that a user has some objects which is called scheme, but you can't grant user 2 to be granted user 3 because it's a user in Oracle, it's not a role. So user 2 can't have grant for all objects within the scheme because the scheme does not exist, and you can't grant user 1 to become a user 3 because they are different entities from roles. Oracle have some kind or concept of system privileges and object privileges. In Postgres, there's not such a strong difference, but we can think that the login permission is a kind of system privilege, whereas most of the permissions are object related. So you can grant select on table, and you can grant something usage on a scheme, for example, or connect to a database for sure. Yeah, I'm a bit out of time, sorry. Oracle Remote Access, the SQLnet Aura, as I have mentioned, Postgres HBA and conf file is there. The difference is that the Postgres evaluates the username and data IP address, source IP address, and the database name before it tries to connect to a database and validate the passwords, whereas within Oracle only the invited or excluded nodes are evaluated before, and as a part of the session establishing the password and the user itself is evaluated at the Oracle level. Please be aware, by default in Oracle, all procedures are considered as define rights, unless you compile the procedure a different way. On Postgres, it's exactly opposite. It's a security invoker. You can change it in both platforms, but be aware this is a significant difference. And since Postgres has only functions, new procedures, you can't control transactions within a function. What you can do within a procedure in Oracle. So you can't commit or start a new transaction within a function. It always runs in context of an existing transaction. Feature I really, really love is a macro that you can grant all. Usually an application developer deploys an application and the guys from the support want to have a select privilege on all of the tables within the database. Well, you can create a PL/SQL procedure and spool it, execute it. This is, of course, possible as well in Postgres, but you can grant select on all tables within a scheme, which is very convenient. But things are even better. With the next version of Oracle, the developer again forgot to grant the select privileges for the support team, so you have to grant all of the objects once more. With the Postgres, you can define a default privileges. For example, and I'm using it if you have a support select only role, you can define it that the default within the scheme or within the database will be granted. So once a new object appears in the database, the default privileges are applied, so you have no more stress with maintaining access for the support department. Now think about Oracle and Postgres. Within the Oracle, you probably run the patch set updates or security updates, and it's more or less a nightmare. You have to install the binaries, not that difficult, and you have to run a set of SQL scripts, usually considering some difficulties, and you need to contact support, especially the data patch fails so often and needs to be worked around. Whereas in Postgres, the minor versions, this is the third letter after the version number, 9.6.2, this is the minor version, you simply need to stop the engine, install the new binaries and start it up, that's all. Please always read the release notes. There might be, but very rare, cases when you need to do something within your database for the minor version upgrade, but usually they are extremely fast. Clusterware, for Postgres you might use some kind of operating clusterware such as a pacemaker built in Red Hat, which might be used if you are an enterprise that you have storage replication between data centers that way, or there is a module or a package which can control the streaming replication using pacemaker, but it's a bit tricky. Patroni HA by Zелени is a nice piece of software which might be used to control the streaming replications and promotes the replica to begin a master in case of failure. So this might be subject of your interest. And there's nothing like Oracle real application clusters in Postgres. Postgres has decided to go for sharding, which is shared nothing strategy. You can see it in Postgres XL. And Oracle itself decided that there might be something good on the sharding. So with the release 12.2, some support for sharding is even included in Oracle. The replication, as I've mentioned within the wall level, log shipping for Oracle, you might transmit the redo by log writer synchronously or asynchronously. You can delay the application. For example, if you are interested in data security, the changes are delivered to standby on Oracle, but not applied before a certain amount of minutes. And you can create logical standby, active data guard for being able to query on the standby, and the golden gate. On Postgres, the log shipping is there. If you want to use it, I would encourage you to configure the archive timeout parameter, which forces the switch the 16 megs xlog file to new one, even if it's not full of data. So you can control the RPO that way. If you decided to go for the streaming replication, the asynchronous replication is the default, but you can switch to synchronous replication as well. So the RPO might be 0, and the cost of you have to deliver your changes to a remote machine. And you can delay the application the same way as in Oracle with recovery when apply delay parameter incorporate available from version 9.4. Hot standby, you can create a logical standby based on some trigger solution like a Zeleni, or PG logical, which is probably to be commented in version 10. So you can select which tables will be replicated, within the logical data guard, and you can create additional indexes or different tables on the standby. Whereas the streaming replication is enough to have a read-only access on the standby, which is equivalent for the active data guard. And the BDR, which is a bidirectional replication, is a proprietary product from the second quadrant. It's almost equivalent for the Oracle Golden Gate. PG SQL command line client. It's very comfortable comparing to SQL+. But please be aware, by default, the auto-commit is enabled. It makes me scared as an Oracle DBA for a long time, and I have to learn that I have to be aware that the auto-commit is there. Starting from 9.3, I think, Postgres has the ability to use checksums for data pages and data files. Unfortunately, it's still not the default. So if you want to have the checksums, and if you are Oracle DBA, you probably want them. I was missing it in version 9 when starting to learn Postgres. Amazingly good option, something between 1% and 2% overhead. I have never touched it to be a problem, but it gives you the security. Once you read the data, you will know if they are malformed because of disk corruption or whatever. But please be aware the backup operates at the file level. So during the backup, you will not realize that there is a wrong data and the checksum does not fit. But you might use the PG dump even if redirected to dev0, which reads all the data, and this will report the issue if there is a data corruption on disks. Available from 9.3. Partitioning. Partitioning in Postgres is based on the inheritance feature. So for Oracle DBA, it's quite difficult to adopt it because the partitioning in Postgres in Oracle works very well. There's no declarative partitioning in Postgres. Improved version seems to be, no, it's wrong, it already has been committed to version 10, so you will not need to write your own triggers to redirect the data from the master table or the parent table to the child tables, which you can do statically if you have a limited constant amount of partitions, or dynamically if the partitions are, for example, based off months. And you can't create global indexes on the partitions. Do we have some time? Probably not.
Yeah, we have. We have about 10 minutes, if it's all.
Okay. I have, I think, 6 or 7 more slides, so we can go through them. There is a time for questions.
Let's check if there are any questions. Если вопросы, я могу для вас перевести, если не можете на английском. Apparently there are no questions, so bonus slides.
Okay. Database backup and recovery. On Oracle, you can export, import using the old imp tools or data pump. In Postgres, you have pgdump and pgrestore. Pgdump all, which is suitable, I think, to create a dump of the globals defined at the cluster level, but I would not advise it to you on for the whole cluster, including the data. So usually I use a combination dump all for the cluster-wide globals and pgdump for a certain database I want to backup. It's nice that the directory format supports parallel dump, which speeds it up a lot. And as I've already mentioned, there's no snapshot to alt error risk thanks to multi-version concurrency control architecture. So you can run the dump and not be scared whether it will finish within 10 minutes or 10 hours. Binary backups. I don't know the version of Postgres when it was included, But well, offline backup works for any kind of engine, almost any kind of application, so it's no more important. Online database backups you can create it manually in Oracle with a begin backup and copy the files and the end backup, or you will use the Armin utility. Most probably this is the choice. Within the Postgres, we have a functions PG start backup and stop backup. Works almost the same as in Oracle, but there's no table space scope level available. This makes sense because the table space might hold the data from multiple different databases, but you can start a backup. What happens behind the scenes that Postgres switched to the mode which is called full page writes. So to the transaction logs, the whole pages which has been modified during the backup are written to ensure the possibility to recover even during the backup, even if the failure happens during the backup. And the stop backup will restore or recover the function of writing the differences. And there is a nice tool called PG-based backup, which creates a copy of your cluster and calls the start backup and stop backup behind the scenes. So this is, I think, the most preferable way how to backup your Postgres databases, unless you decide you want something a bit more automated. Personally, I use PG Barman. I think it's a product from second quadrant, but it looks almost similar to Oracle Armin. If you are using Oracle Armin, you will be able to adopt PG Barman. It can manage for you amount of copies or some recovery window, just exactly what you can do with the Oracle Armin. Stored archived logs together with the Barman backups. So if you want to restore and to recover from your backup, you have all things in place and you don't have to manage it manually. You have some reports from the backup, so how many backups you do have, how big they are, how old they are. And then I think it does not use any kind of Armin catalog. There's no equivalent. It simply reads the files on the server where you have stored the Barman backups, and the metadata are grabbed from the things you have available on a disk. By the way, there's no media manager layer or something like this, so it always creates the backup on a disk only. But thanks thereto, we do not have any kind of Armin catalog or things like this. We can archive to a tape a certain directory and it simply disappears from the list of available backups. But if you ask your backup software, please give me the old directories already backed up, we can restore it back and the Barman will report it's a visible backup and we can do restore from that backup. So you might have stored 3 days of backups for 3 days on your disk, and the older backups for 1 month might reside on the tape, and you still be able to restore them from the tapes to the disk and use it for restore. I think it's really, really nice feature. PG Backrest is a product. The link works to the company, but it's from US. I think it's more complicated than Barman, but it promises some kind of incremental backups to work slightly better. Within the Barman, you can configure the incremental backups, but it works at a file level, so it makes sense only if some data files are not touched, for example, are part of 1 year history and you have daily or monthly files. PG Barman is able to realize that the file hasn't been touched and modified itself, but it used simply the diff. So it's not a block level incremental changes. Postgres Pro with their Enterprise Edition of Postgres implemented an incremental backup which creates a block change tracking file.
May I correct you? If I'm not mistaken, PG Pro Backup is on GitHub, it's open source, it's just call it after Postgres Pro company. It's not an enterprise feature, from as far as I know.
But to get it working, you still need the block change tracking. You need to have a map of what blocks has been changed from the last backup, and I think it's not part of the Postgres, but might it be it's available as an extension. Yeah. On the slides I will provide, there is a link to the Pro Backup product, so you can check the details. The barman can act as the replica. So thanks to the PT receive xlog feature, you can ship the transactions as a streaming replication. So it might be synchronous or asynchronous, the same way to streaming replica or a standby database in Oracle naming convention. So the RPO might be 0. You can receive the data and it will be confirmed as a committed only when it has been received to the barman storage. So you can recover with a RPO of 0. And for sure the replication manager is an additional tool which can combine the barman and the standby instance to minimize the RTO, I mean the switch time to the standby, and run the recovery automatically. Within Oracle, probably you use dual. There's no dual table in Postgres. I've been rushing for it for a long time before I've realized just select the function or select some division. What is nice, the copy command of Postgres. Well, with version 12, Oracle realized that there are comma-separated values files and you can use them, but until version 12, they do not support it, CSV files. The copy command can be called at server side or at a client side, and it is an extremely efficient way how to load a data from a file system to your database. If it's on server side, the data you are about to load might reside and be accessible by Postgres processes. Or if it's a client side, there is a overhead of the network transfer, but you can use exactly the same function to load the file on the server side or from your client station, transfer there to the database over the network. It is much faster than if you create insert statements for 1 million of rows, even if you put them all in one transaction. And I think from Postgres is the feature called foreign data wrappers. You can use a file foreign data wrapper, which is almost equivalent of the Oracle functionality called external table. But the foreign data wrappers are more general. So you can create a foreign data wrapper you use to connect to Oracle database. So that way, your Postgres instance might be not a database engine only, but it might be kind of integration middleware, because you can connect to SQL Server, you can connect to Oracle database, you can connect to various internet resources. So with some extensions implementing foreign data wrapper, you may download some data from internet, use them to build a materialized view on top of them. And this way you switch your database to act as a kind of middleware. So the foreign data wrappers are extremely flexible interface to interact not only with other databases, but with various other resources of data.
1 minute.
Okay, I think we have one more slide.
Actually, there are no talks after this one, so здесь ничего не будет происходить до 2 часов, поэтому вы можете оставаться, потому что можете пойти поиграть. I told there is no talk after this one, so people could stay, could listen, etc.
Okay, it will be pretty fast. So some functions seems to be similar, but they are slightly different, so check the documentation. Usually, most of the functionality you can find in Postgres, but please be aware there are no pipeline functions in Postgres, and because the PL language in Postgres is based on ADA, most probably they will not be available soon. So this might be some things to remember, no pipeline function in Postgres. And then I think that Within the group by, you can use aliases within the group by, what is not possible in Oracle. So this is some kind of convenient feature for writing your statements. Few more things, table spaces. Oracle provides quotas for table spaces, and you can limit what amount of data a user might occupy in a table space. There's not such feature in Postgres. That's why I always create a new table space for a new database, and that's why I drop the public table space. So unless a user is granted to use a table space and a scheme, they can't create their own object and do some kind of DDoS attack, just filling the file system by the flood of their own data. Create table space might be granted in Postgres to a role if you want, but usually it's not necessary because you do not issue the statement so often. Oracle containers. There is no concept of ownership for Oracle containers. Honestly, version 12.2 brings some changes, so the containers might not be the useless as it seems in the version 12.1, but any kind of grants is always in scope of database. Within the pluggable database from Oracle, the global user exception exists, but in Postgres, users are cluster-level objects, so you can grant a user, the role with the login permission, to have access to multiple databases and multiple schemes within the databases. A database in Postgres might be owned by a specific role, which is nice because you can delegate the responsibility for a particular database to a development team or to an application support team, based on what is perfectly suits to you. And the search path. The search path means which namespaces or schemes will be searched. Works exactly the same way as a path variable in a file system. So you can use multiple schemes to be searched within the order as they are mentioned, and you can do it at the configuration of your cluster. You can alter a database where a user connects, so you define a search path particularly for the database. You can alter a user to have their own search path, and search path can be set at will on the user level. So within my session in PostgreSQL, I can use an alter role. I can use the command set search path to and change the order in which the schemes I have granted will be searched. PG catalog is always part of the search path, even if you are not included, so you have access to the metadata for your database and your cluster. Oracle Advanced Security, transparent data encryption, Kerberos integration, and many other features like virtual private database and row-level security. Costs you some money. With Postgres, you can integrate with Kerberos or Active Directory. You can do it. Row security policies is almost what Oracle means with the row-level security. Transparent data encryption, there's no equivalent in Postgres, but Cybertech has implemented a small patch, which is not part of the core, but publicly available, so you can encrypt your whole database on a disk. I think they've modified only 4 source files of the Postgres to have it implemented. And there is an extension called PG Crypto. You can use it to protect your sensitive data. Public synonyms, they are often overused in Oracle databases, but I think at least the private synonyms should be used for security reasons. If you want to attack a database, a public synonyms might be something what you discover as a path where to drive your attack to a database. Within the Postgres, search path environment variable defines the scope of visible objects. So it's a list of namespaces or schemes you have access to a database. And this is the very last slide. Thank you for your attention.
Да.